In this video, we're going to talk about chord and arc properties. So as you can see here, I have two chords that are congruent. I can see that because of the dashes. And the conclusion that I want you to draw is that since these chords are congruent, the arcs that are attached to them are also congruent. So that would be this arc here and this arc here. So the statement we could make is, if the chords are congruent, then the arcs are congruent. Therefore, if chord AB is congruent to chord CD, then the measure of arc AB should be congruent to the measure of arc CD. And I can say the same thing pretty much backwards. If the arcs are congruent, like you see here, then I can conclude that these chords are also congruent. So I can make the following statement. If the arcs are congruent, then the chords are also congruent. So therefore, if the measure of arc AB is congruent to the measure of arc CD, then chord AB must be congruent to chord CD. And we can use those definitions to work on the examples below. So in this first one, I can see that chord CD is congruent to chord FE. And because they're congruent, I know that the arcs attached to them must also be. So if this side is 106, I know that this side must also be 106 degrees. Since I know that a circle in total is 360, I can just take 360 and subtract everything that I know, and I will get this missing piece, which is X. So I'm going to subtract 106, subtract 106, subtract 33, and that's going to give me a total of 115 degrees. In the second one, they only gave me one arc, which is 108 degrees, but they did give me 3 congruent chords. So since all of those chords are congruent, I know that all of these arcs must also be congruent. So what I can do is I can take 360, subtract what I know, which is 108, and I get 252 degrees. And since I have 3 equal chords left, I can divide that by 3, and I'm going to get 84 degrees. Last but not least, I see that I have a set of chords here. From here to here is 10. This piece is 2. This piece is 2. I can see that I have these arcs here that are congruent. These pieces are already equal. So the only piece that's really missing is that one. So I think you can see that that is also 10. Let's talk about the relationship between the diameter and or the radius and a chord that it is perpendicular to. So what you can see here is that if the diameter or the radius is perpendicular, which means creates a 90-degree angle to the chord, then it bisects the chord and the arc. So as you can see here, I have a diameter and a radius going through this chord. It creates a perpendicular intersection. So not only is the chord cut in half, but the arc that it is attached to is also cut in half. So I can draw a similar conclusion thinking about it backwards. In the second circle, I can say, if there's a perpendicular bisector of the chord, then it must go through the center. Which means it must be a diameter or a radius. So now let's use that information to follow and finish the problems below. So in this first one, I am trying to solve for x. I can see that x is the radius. I can also see that I've been given a hypotenuse here, which is 13, and a bisected chord here. So if this is 5, I know that this piece must also be 5. And with that information, I can use the Pythagorean theorem to find this missing leg. So a squared plus b squared equals c squared would leave me with 5 squared plus b squared equals 13 squared. I'm going to get 25 plus b squared equals 169. And when I subtract 25 from both sides, I'm going to get b squared is equal to 144. And my last step to get b by itself would be to take the square root. So b would equal 12. So if this entire leg is 12, I can add 2 to it, which is this piece, to get the diameter. So that means that the diameter is equal to 12 plus 2, which is 14. X, which is the portion that I'm solving for, is only the radius. So if the diameter is 14, I can cut that in half, and I can find that x is equal to 7. In the second one, I see that I have a radius creating a perpendicular bisector here in this chord. And I see that this is 4. So if this whole thing is 10 and it's being cut in half, that means this piece is 5 and that piece is 5. And again, I'm only looking for x, which in this case ends up being the hypotenuse, because if this side is 90, that side is also 90. So here I have 5 squared plus 4 squared equals x squared. 25 plus 16. When I add those together, let me flip this around, 41. Last step would be to take the square root. So I'm going to get a decimal. X is equal to 6.40 since it asks for 2 decimals. Last but not least, this is asking me to solve for x, which happens to be the radius. I've been given a particular set of information. So here you want to get a little creative. This is also the radius. So if I solve for that piece, I will also be solving for that piece. So again, I have a right triangle. A squared plus b squared equals c squared. I'm solving for the hypotenuse. That's why I have that piece missing. Add those together. X squared equals 25. And what's the last step to get x by itself? X is equal to 5.